Hi, everyone. Both Brad and I are extremely excited to be here. To briefly introduce myself, I'm Sophia, MIT alum, have my brass rat on, and current partner at Greylock, investing in AI native applications and infrastructure. I was previously at Character AI and Scale AI, where actually Brad was my CTO. So I'm extremely excited to be here moderating his panel today. So to start, Brad, you went from leading robotics at Amazon to leading engineering at Scale AI, which was an AI infrastructure company and data company. And then you founded Cobot, which is now back to robotics. So tell us more about your journey and what pulled you back into robotics.
Yeah, thank you. It's great to be here, everyone. I kind of thought I had the best job in the world in robotics. I was leading a 10,000 person org at Amazon. We went from 50,000 robots to 500,000 robots in 4 years. And so I learned a lot about what it took to be successful with deploying robotics at scale. But I'd also always been like AI adjacent in the work that I'd been doing. Tell me networks, we were speech recognition. And so I understood the critical importance of data to the ecosystem. And so when the opportunity to join Scale came up, I was super excited to do that. But then as I saw what was happening in self-driving, in AI, and what was going to happen in robotics as a result, I just realized there was an opportunity to build a new product, a new capability that would get better as AI got better, and it was too good an opportunity to pass up, and so started Cobot in 2022.
And so in robotics, there's this term physical AI. What does that mean?
Yeah, physical AI, obviously the different people apply. There's no kind of precise definition, but I think if you talk to roboticists, right, who are believe they're working at the edge of physical AI, it's really about very high dimensional controls and sensing and actuation, right? How do you take vision, touch, various different modalities of input and then perform action in the world? And we do that today with plenty of existing robots, but often in a fairly low control regime, like in 6 degrees of freedom, roughly, right? The 6 degree of freedom robotic arm. Because at that scale, you can write the controls algorithms mathematically, and you can verify that they're safe, and you can prove them. But if you want to control the human hand, right? The human hand's about 42 dimensions of actuation. The synthetic human hands, robotic human hands, are as many as 26 dimensions. It's very hard to write a robust controller of 26 dimension. You can't really write that as a controls engineer, and so you need to learn how to do those manipulations. And when we think about physical AI and we talk about kind of the ChatGPT moment for robotics, what we're looking for is not something that can just fold laundry, right? But that can do all of those tasks and capabilities. I like pull the like AirPods out of my, like, how do you do this, right? Can you do it with one hand? And we do that without really thinking about it. But robots today, you can train one at a time, one task at a time, but you don't have generalized physical AI yet.
Yeah, I mean, you have a lot of expertise and background in humanoids, and Cobot, maybe to help the audience, could you tell us what Cobot does and also why you decided not to build in humanoids?
Yeah, so the insight for Cobot came, when I was leading robotics for Amazon, I had the team do analysis of humanoid robots and what at Amazon were we not going to automate otherwise, where a humanoid would be valuable. And we found over 40 process paths at Amazon where a humanoid would be valuable. But then we did the reverse analysis, which said, is a humanoid actually what you want for all of these process paths? And in no case was a humanoid what you wanted. In fact, in no case did bipedalism, two-legged motion, help you at all in any of Amazon's facilities, right? Amazon doesn't have people climbing stairs. Like, it doesn't exist as a task at Amazon. Because you have carts, you have wheeled things, you have floors, you have lifts, and so as we looked at it, we just didn't think bipedal. You also want swappable batteries. You want stable perception. There's a lot that you want things that are strong. Humanoids are just not very strong. They're not as strong as humans. We kind of projection map Transformers the movie onto these physical humanoids. The actuation is, at best like 60% of human strength. And then you want things that are safety rated, and how are you going to, a balancing system, and then the energy required in a balancing system versus wheels, and then if you want to go more than 3 miles an hour, it's just like all these reasons just add up to a humanoid is not what you want. But there was a gap. We did see a gap in the marketplace where there wasn't a solution for these 40 different process paths. There wasn't something that could just do human scale work, move boxes, totes, and carts, and was going to get better as the AI gets better. And so when we started Cobot, we decided there was just a big missing gap. We also learned at Amazon that automating walking was the most cost, labor-saving opportunity. Turns out paying people to walk is a pretty low value of use of human capability. And so we focused on a robot that could eliminate a lot of the need for just traversal in warehouses, manufacturing, hospitals. So we'll run a little video clip here. I'll show you what Proxy is. This is obviously in digital twin before we had a real robot. This is a transload facility that Maersk operates. And so we started out testing last year, just proving that we could move these carts. So these are just industrial carts, 2 snapcasters on the front, fixed wheels on the back. It turns out no one has a robot that can move these. But the technology is there, the sensing, the perception, the AI works. And so we're now moving, we have 15 robots moving 2,500 carts a day in this facility. The carts weigh up to 1,500 pounds, all autonomously. In fact, yesterday was the first day we did 100% of the carts fully autonomously. Like not a single cart was moved by a human. And then this is Mayo Clinic. We're same robot, very different process path, moving in a specimen lab. And in fact, 3 weeks ago, we went into the main hospital of Mayo Clinic, moving amongst, I get emotional about it, there's a story behind it, moving amongst the patients and staff, ramps, floors, elevators, and we're moving GI scopes from a procedure area to a cleaning area, but we'll start doing a lot more for Mayo soon, and then continue to expand from there.
Yeah, love the use cases and love that they're being used today and like achieving those metrics. How do you think about the other use cases to tackle?
Yeah, so we started with moving carts, and turns out moving carts exists everywhere, like logistics, manufacturing, hospitals, but also airports, stadiums, campuses, office complexes. And so we wanted a robotic capability that could do a lot of meaningful work in the world today with today's technology readiness, right? I think if you go and you see more now. Obviously, humanoids have these high dimension actuation, but people are starting to do more where they've kind of put two arms on a mobile base. The AI isn't quite there yet for that task. And I mean, I know exactly where all the manipulation AI is because we were driving all of that work at Amazon. Amazon's continuing to make a lot of progress, and I think Amazon with covariant acquisition remains well ahead of almost anyone in applying sophisticated AI manipulation to real-world use cases. But, at Amazon, we were doing that since 2017, right? And then covariant was maybe founded in 2018, right? And so, it's a good way to spend 7 years in pilot to go prove that you can do bimanual manipulation. And so we wanted to start with a use case that we knew we could do. But you can see with this this robot that today we're just grabbing the horizontal handlebar of carts, but in the future we can grab boxes, totes, and then over time, as we get that high dimensional control AI, we can start to pick and place and grab and the use case I think about at Mayo is like, how do you go to the refrigerator, open the door, grab a Jell-O, grab a spoon, bring it to the patient's bedside, help them get their phone, help them get their glasses. If you can have that kind of manipulation, then you can really help nursing. You can help in lots of different ways. And so we have the robot that builds to that progression, but we're out there doing work right now.
And you have a lot of experience scaling the productionization of these robotic systems in the past, and you have these robots already in action today. What would you say is the hardest part about moving from prototype to production?
I think the hardest part is finding customers excited to go on that journey with you, because you can't really do it all in the lab. Right? You have to get out in the field, but you're now getting out in the field with early technology that isn't, fully baked, fully ready yet. That's why the 100% of cart movement yesterday is a huge milestone. We've been working with Maersk for a long time, but they've been pushing us to say, hey, when can you get all of them, right? And in fairness, like we went into their facility, first cart moved May of not this year, last year. So, finding a customer that's willing to go on that journey with you for, 16, 17 months. And yet, the beauty of it is for Maersk and for Mayo and for our early customers, they get to influence the roadmap. They get to, work in, day out, make sure the robot really fits their needs. And so, but I think that's what robotics companies have to do. You have to find pilots that are going to expand, but you're going to bring technology that doesn't yet fully work. And so I think that's the trickiest part.
Yeah, and looking forward, when you think about what's going to push robotics to the next frontier of capabilities, what advancements do you think will be most impactful? Like, do you think it would be advances in multimodal reasoning, tactile learning, foundational models in motion, or something else?
I think the foundational models of motion are going to be the real unlock, the physical AI is, but I think we haven't yet really tapped what you can do with large language models in operating, in production operations, right? Our robots have a microphone, have a speaker, they can talk to you, they can listen to you. We mostly use them right now to talk, to announce where they're going, to announce what they're doing. And it's a really different experience. Like, there's not a single robot at Amazon. Amazon has over 1 million robots. To my knowledge, there's not a single one of them that talks to you, right? There's not a single one of them that tells you what they're doing. At best, they blink some lights or they like flash something on a screen, right? But now to have a robot say, hey, I'm going over here, or even just like, we're going to get to ones where they say good morning, right? And just like, or good morning, Joe, right? That capability exists today, but it's not being deployed in production robotics yet. We're just starting there, but I think it's going to be a very different experience. In fact, I have a video of kind of a hackathon that shows, well, to me, it was kind of a surprising result of embodied AI. So I'll set up the kind of context, and we'll show this video. The context, we were doing a hackathon with Hippocratic AI, which has AI for nursing, right? And another impressive technology startup. And so we were fusing their voice-based, generally, system with our robot to create kind of an embodied AI experience. What would a virtual nurse in a hospital, not really a nurse, but maybe a nursing assistant on a robot look like or feel like? And so the hackathon was what one of the teams did was to build a multimodal model that could detect falls, right? And so combined with their AI for patient care, detect a fall, and then intent is call for help. So here's a video of this, the result.
Do you have any questions for me while we walk?
Oh.
Oh no, are you okay? Did something happen?
Yeah.
I think I know what's going on here. You're saying that you're not doing well, but I can hear some laughter in the background. You're sitting down, so I'm assuming you didn't actually fall or anything. Am I correct?
No, it's too smart. It's so cool. That's what it is.
So I think embodied AI is going to feel different than we expect, because I think there's more intrinsic capability in these models when you start fusing vision and voice and situational awareness. And that one kind of, I was standing in the back, and I'm in those gray pants back there, I think, and I was just like, wait, that wasn't what I was expecting either. So it's going to be exciting, but it's going to feel different, I think.
Brad, thank you so much for sharing with us your expertise, and hope everyone all has a great rest of the conference.
Thank you, everyone.
For Brad and Sophia, great job.